welcome back to my channel Learn with Nikhil. So in this video we are continuing with the second topic, that is CAD for additive manufacturing. So the contents we'll be covering in this chapter will be, first we'll define what is CAD, then different types of CAD data formats, then the basic principle of additive manufacturing, the need for the STL file, we'll study about the STL format, then the data loss arrives, need of slicing, and then the advantages and disadvantages of CAD. So it's a simple structure. Let's begin. So definition of a CAD. So CAD is basically a computer aided design. It is used for computers to aid in a creation, modification, analysis, or optimization of a design. This software is used to increase the productivity of the designer, improve the quality of the design, improve communications through documentation, and create a database for manufacturing. So CAD is an overall package which aids in the creation, modification. You can do the changes easily. You can, whatever changes are done, it can be communicated directly, indirectly, and it also can be documented. So there are proper procedures and methods which can be used for a successful CAD design, because for a CAD design to get successfully, there are many factors or many persons involved in the entire process. So there needs to be proper channelizing and documentation of the work. Moving to the next topic. So different CAD data formats. So here I'll be explaining few of the CAD data formats from different perspectives or different angles. First one is AutoCAD. So as you can see, this is the basic example of AutoCAD. So AutoCAD is basically used for mostly for 2D. So if you want to model any building, architecture model of a building, so 2D structures can be easily made in this, and you can convert this into 3D also, but mostly it is used for 2D drawings. Next is Blender. So Blender is one more powerful application. It is a free open source application which can be used to do animations. You can create sculptures, models, 2D, 3D conversions. So basically mostly 3D conversions are done. So modeling, human face modeling, entire animation, your game, whatever the artist in the games are there, you can create those, you can animate those, then transfer these files into different formats, so which can be used for different purposes. So very powerful, but an open source free software. So next we are moving to Parasolid. So Parasolid is a geometric modeling program, and it is a file extension, contains 3D CAD file information like geometry. So we have all the geometry, color, and topology color from your drawings. So we get all this things. So it is similar to like SolidWorks or AutoCAD only, but it gives some more extra information provided. Next we have SolidWorks. So SolidWorks is the mostly widely used in mechanical any parts designing, automotive parts or any mechanical parts you have to design. So SolidWorks is widely used. It is very professional, and most of the companies are opting this software. So the file extensions we have is SLD PRT and SLD ASM. So these two file extensions, basically this is called as solid part, and this is called as solid works assembly. This provides details on specific parts. So as you can see, it gives details to the specific parts within the entire system, allowing it to study and reassess the overview of the entire 3D diagram. So the modifications can be easily done. You can convert this entire 3D into 2D, and then give the namings, dimensions properly. It can be printed and it can be forwarded also. Next is Inventor. The file extensions are IPT, .ipt and .iam. So it is similar to SolidWorks. As you can see, again you have some mechanical design, automotive design here. So parts and assemblies can be done. It is a single item design or bearing, anything can be done. So it is similar to your SolidWorks only. It has more interactive part. So interacting part, the animation part. So like for example, a screw is going through a nut. So animations can be easily done in this Inventor. Next you have SketchUp. So the name suggests SketchUp is developed by the LAS software, and it is a CAD file format brought to Google in 2016. 2006. So it is again similar to your AutoCAD, and it gives two-dimensional, three-dimensional structures. So as per your need, you can use different types of CAD formats. So these were the basic CAD formats used, and finally the STL. So STL is a widely used CAD format. So for our 3D printing, whatever CAD formats you have, you can see here various CAD formats. So this is a screenshot of a Blender. So it can convert into various CAD formats. And for 3D printing, we are using STL. So this STL file is uploaded into the G code, that is the slicer format, and then you get the G code files. So STL is widely used for 3D printing. Many more STL formats are there, but these are the basic and widely used STL formats. So next, moving towards the basic principles of additive manufacturing. This we have already studied in chapter number 1, but then also you will just revise this in short. So firstly, we have to make a 3D object. So whatever object we want to make, we have to prepare that CAD model. So for this CAD model, again, you can use any CAD software, as we have seen earlier in our previous slides. So this is the screenshot of a Blender. So we are making a cube. Then we have to get this, download this into STL format. So downloading, importing, exporting this into STL format. Then we get this type of STL file. You have to save it in your PC. Then moving forward, so we have to transfer this into the slicer software. You have already seen. If you want to know more about the slicer software, link is there in the description below. Also, it is there upwards, so you can go through it. Entire slicing about the slicer software I have explained in detail. So you have to get into the slicer software, then it converts your entire object into slices. Then we have to load this G code. We get the file format is G code, and we have to upload this G code file into our 3D printer. So we are uploading this into 3D printer. This entire video is already, I have explained this in the first chapter. So you can refer that. So I'll not go back again. So you have to get the G code, upload it into the software, and then you have to click on print and it starts to print. So refer that. So moving forward, so this is the final product which we get. So we have to do some post processing, like you have to do the polishing if required. If there are any supports, you have to remove the supports. So you have to do some post processing like coloring and everything you have to do to make it a perfect object or a usable object. Next, moving forward. So now, what is STL? So STL, the file format which we have downloaded. So as we have seen in our previous, we had exported the file in STL. So STL is file derived from the word that is stereolithography, which is the first commercial AM process, that is additive manufacturing process, produced by the US company 3D Systems in the early 1980s. So STL word is derived from stereolithography, that is ST and L. It has many different long forms also. It is also known as standard triangle language. Why it is called as triangle, I'll explain it in a while. And it is also called as standard tessellation language. So now this, what do you mean by standard tessellation? Tessellation is a process of tiling a surface with one or more geometric shapes such that there are no overlaps or gaps. So for example, you can see it here in an image. So this is the image of a house or a wall. So as you can see, it is divided into smaller triangles. So these triangles are not overlapped on each other, and it gives the entire structure. So joining this triangle gives the entire surface. It covers the entire surface. Here also, so this is a rectangular shape, but in STL we are mostly using triangles. So this is just an example. Rectangular shapes, they are aligned side to side each other without overlapping to cover the entire surface. So that process is called as tessellation. So that's why it is all called as standard triangle language, or also it is called as standard tessellation language. Okay. So moving forward, so STL is basically a facet boundary representation. Facet matlab, it is around the borders. It is a facet boundary representation model of an object, any object that approximate the model surfaces by connected series of triangles. In this image you can see, so this is basically a facet boundary representation. It covers the entire surface, and the entire surface is connected by a series of triangles. So you have small triangles, you can see. So our whole entire model is made up of smaller triangles. So STL file is basically standard triangle language. So it is divided into triangles. So a whole object is divided into n number of triangles. So compared to this image, you can see the number of triangles have increased. So it is basically like a resolution. So the more higher the resolution, the more quality of the object will increase. So you can compare these three images. The triangles over here are the most. So the finer quality of the version of the print will be there. In this, there will be some, the print will not, that it will not be that good. Here the print will be much better and this will be the best quality. But the disadvantage will be that here will be having number of triangles will be more. So the memory allocated, the memory saved will be much more. So memory utilization will be more, but the quality will increase. Also the printing time for this will be more. Printing time will be though the finer quality requirement, the file memory will be more. Now, it doesn't contain any information related to color, texture and density. So it just contains the outer boundary of the model, the boundary information of the model. It doesn't contain the information like which color it is. So even if you make a total colorful model in the any Blender software or anywhere, when you download it, it will be a normal color. It will not have any color. So anything you make, it will be downloaded in a normal HTML file which doesn't contain any information of color or texture. Okay, so moving forward, so here it is one more example. It is given. It's a sphere. So this is the exact HTML file. Then it has a coarse, means a lower quality, and this is the higher quality. So you can see the number of triangle size. It is 2000, around 2000. Here it is doubled. The file size is also doubled. The file format is SCI or binary. So HTML saved in SCI files, or mostly it is used. A binary file is used. Binary file format is used. So one more example. An STL file describes a raw unstructured triangular surface by representation of a unit normal and three vertices. So in this image you can see you have a unit normal. So this is the normal and it has three surfaces. So this triangle, this smaller triangle, so it is the zoom part of one triangle. So it contains the information about these three coordinates, that is P1, P2 and P3, and it has a normal. This normal is perpendicular to this triangle and in the direction of the normal. So there is a theory that derivation that in the direction of the normal there is no object. So the triangle is totally covering. So if the object is like this, so the normals will be pointing outward, perpendicular to that. So here it is. So there is no material available in the direction of the normal. So no material. So this is the object. If this is a sphere object, all the uh, normals will be pointing outward. So here the normal will be pointing like this, outward side. So here also it is coming out. So this is the basic representation of the HTML file. So more triangles, the more memory size will be there and more accurate the object will be. So finally, for finding the or placing the triangles, you have to find these coordinates. So there is a mathematical derivation. I'll not go much into detail of that, but this is the outer shell of what HTML represents. So again, the same thing, but in much detail. So you have this P1, P2, P3 point. This is the normal point N, which is pointing outward, just in much detailed version. So this is nothing but the coordinates. I told about the mathematical calculation, how this is. I will not go much into detail of this. So moving forward, so why we are using triangles only? Not any other square, hexagon. Why we are not using that? Why we are using only triangles? So the advantage of using triangles is that so it has some certain characteristics. So any three non-collinear points forms a triangle. So any 3 points, non-collinear points forms a triangle. So any 3 points you have, which is on a single surface, it always represents a triangle. Then every triangle forms a unique plane. The triangles, if you cut any triangle, okay, so there is a triangle. If you cut any triangle, you will have a smaller triangle itself. Okay, so cutting the triangles, you will get triangles only. Okay, so this is how it is. So if you cut a triangle, you will get this 1, 2, 3, 4 triangles. And also here you can see. So here, if a triangle, a boundary, this is a shape. So if you bend from this line, you can see it over here. If you bend from this line, then you again get a triangle. So bending anywhere will get a triangle only. So That's the reason we are using triangles. So any surface, as I mentioned this, any surface can be broken down into triangles, and triangles can be broken down into only triangles. So more divisions you make, the more triangles will be there. So that's why we are using triangles. Then you have advantages of STL. It is widely supported. Most of the CAD software, almost every CAD software will be supporting this STL format. It is lightweight. The conversion is quite simpler and it is fast. So that's why it is called as lightweight. It is easy to generate. It is accurate. The representation is quite accurate as it is using smaller triangles. So it is a very good accurate representation is there. Then it is compatible with, of course, as we are studying 3D printing, it is the best compatible for 3D printing. It is a standard format used by almost in industries, everywhere it is used. So these are the few advantages of STL. There are many more. Few of the disadvantages of STL, it generates a large volume of data. So as I mentioned that if there are more triangles, then it will be the volume of the data will be increased very much. So the surface quality is improved by refining the net of triangles. So it increases the surface quality, but the volume, the memory, it will be utilized very large. Then, as I mentioned in the definition, that STL files only contains the geometrical information, that how the shape is, how the model structure is, but it doesn't contain the information like color, texture, material. So for that, we have to download in other file formats. Then the need of slicing. I've explained the entire slicing software in my previous video. The link will be popped up over here, so you can refer that. And what is the need of slicing? How to do the entire slicing process using our slicer software? I've explained, so you can check that out. So next we'll talk about data loss or errors. So while creating the STL file, there will be some errors or data loss. So let's talk about that. So it is divided into first, that is construction errors. So construction errors are based on unnecessary data inside the component, and that the result of combining the single elements incorrectly in the CAD system. So if you are joining two elements in the CAD system, the joining may not be proper. There will be some gaps left, or there will be the two parts will be inside of them. So those are called as construction errors. So I'll explain this with this thing. So in this Tinkercad, as you can see, so we have just considered one box. We are considering a text. So we'll combine these two objects together. So while combining these two objects, we can see some errors. I'll create some errors and I'll show you what the errors can be. So if you have to keep this XYZ letters on this box, I have to mount on this. So basically it is like a plate and a name on it. So I want to write the name on this plate. So might happen that these two are not joined. So you can see there is a gap in between. So if these two are not joined, there is a gap. Then in the STL file, while printing, it will be printing on top of it, above it. So all the stringing will be there. There will be no joining between these two objects. And in the slicer software, it will slice like that. Or the second thing, if it is much deeper inside, so there is a waste of material. And if it is not joined properly, it is deeper inside, the dimension, there will be dimension incorrectness, the height will be incorrect. So this is some sort of constructional errors. Moving forward, next type of error is transforming error. So transforming error is nothing but when the convergence of a mathematically exact contour by triangles. So the joining of the triangles. So while converting or downloading the STL file, so you have to convert an entire diagram into triangles. So while converting into triangles, there might be some losses, or some triangles will be inaccurate. There will be some losses in the triangles. The triangles will not be present in some of the parts. So those are called as transforming errors. So while converting from one format to another, there might be some losses. Those are called as transforming errors. And the last one is description error. So description error is basically again the gap between the triangle spaces. So if you have two triangles which are joining to each other, so there might be some gaps. There will be overlapping between the triangles, or there will be incorrect orientation. So this is again related to the transforming errors, but these are specifically called as description errors. So these are all the data losses or errors which can occur while doing the STL file. And finally, the one of the last topics of this chapter is the advantages and disadvantages of the CAD. So the various advantages of CAD are it increases the productivity, higher quality designs, reuse and easily change designs. So in CAD software, you can easily change the designs. It is easier to read if you are giving to an architect or any other engineer, you can easily read. The sharing is simplified, you can share it online. Otherwise, earlier we have to carry the larger blueprints and everything you have to carry. Now it can be shared through mail, anything. The documentation of the design is very easy. You can keep the tabs, whatever changes can be made. So these are the few of the advantages of CAD. Lastly, the limitations of CAD are first the skill of the designer. So as you know, the CAD software is quite a complex software. So as you work on it, you will refine your knowledge of the CAD. So you have to, the designer has to be quick. Yeah, he should know all the shortcuts to design. And basically the skill of the designer should be improved. It's not like a working skill, but the CAD using of the CAD software. Also, there are much updations in the CAD software, so he has to adapt to the updations also. Then designing the physical objects into the virtual space, again the same thing. So you have to, as the physical objects have to be designed in virtual space, so the realness of the object doesn't feels like that. So first, then you have to imagine how the shape of any car or any, if you are designing a food material, so there are imperfections in the food actual. So actually if you have to make any like circular, like a sweet dish you have to make, like you can consider a gulab jamun, a sweet dish. So it is in a spherical shape, but it has some many imperfections in that. It is bent from one side. There are grooves, holes. There are many imperfections in that. So if you have to design that in the CAD software, then you have to consider the imperfections, which are the perfectness in the real world. Okay, so that you have to consider. Again, the cost of the software, it is costly, and also the making of it in a CAD, then the entire process of 3D printing is quite time consuming. Okay, so this is everything about the second chapter. So see you in the next lecture. Thank you.